Okay, now let's look at this same birthday problem. Actually, the problem is testing on your understanding of a binomial distribution. The problem statement is that you are attending a party to find a group of n individuals at random to find out if any of them share the same birthday as yours. And the assumption for this problem is that 1 year only have 365 days. Basically, is to excluding the leap year to make the problem simpler. Part A, we want to find out the probability that none of them have the same birthday as you. And then part B is that what is the minimum number of people required in the group to ensure that there's at 50% or higher chance at least one person have the same birthday as you. So you can think this as a binomial distribution. X is denote the number of persons have the same birthday as you, which is following a binomial distribution. Since in total we have n individuals in the group, hence we need to compare each individual n person to check whether they have the same birthday as you or not. And then the success probability is that for a particular person, there are only two outcomes. Either they have the same birthday as you or they have a different birthday as you. Since 1 year have 365 days, the chance that they have the same birthday as you is 1 over 365. Then they have a different birthday is 364 divided by 365. Hence, the 1 over 365 is the success probabilities. Then we can just model this as a binomial distribution with n Bernoulli trial. Each Bernoulli trial is just compare you with an individual person, whether you have the same birthday or not. And the probability you have the same birthday is 1 over 365. Hopefully through this explanation, you can easily see this problem actually is a binomial distribution problem. If we form this binomial distribution problem, then the problem is quite easy to solve. Part A is asks you none of them have the same birthday as you. Since X is denote the number of persons have the same birthday as you, so part A basically is to asking what's the probability that X equal to 0, right? Then we can just use the binomial distribution PMF, p to the power of x, 1 minus p to the power of n minus x. Then we can just easily solve to get a solution. So this is for part A. For part B, we want to ensure that the minimum number of people required in the group to ensure there is 50% or higher chance that at least one person has the same birthday of you. So at least one person have the same birthday as you basically is nothing but the probability of x is greater or equal to 1. We want to ensure this particular probability is greater or equal to 0.5. And here we can just use the complement rule to calculate this. Probability of x greater or equal to 1 is the probability of 1 minus the probability of x is less than 1. And then since x is denote the number of person, and person cannot be negative, hence x is less than 1 is equivalent to say that x is equal to 0. And the probability of x equal to 0 we have already calculated in part A. So we can use live S result to ensure that this is less than 0.5, and then we can find out what is the n that is required, minimum number of n. So basically this is the high level idea on how to solve this particular problem. Now let's look into the solution. So as what I explained, first we normal as a binomial distribution, x as the number of persons have the same birthday as you. Hence we just need to calculate the probability of x equals to 0, which is leveraged on the binomial PMF, and then we just substitute x equal to 0. Hence the first term is n choose 0 is 1. The second term p to the power of 0 is also 1. So we can safely ignore these two terms. And then the success probability is 1 over 365. And then we just substitute in, and then eventually we will get the result 364 divided by 365 to the power of n. Or another way you can solve this problem is that you can just simply think there are 364 over 365 probability that they do not have the same birthday as you, right? For an individual person. Since we are compared with n person, we just can directly to the power of n. So we can use the multiplicative rule to also reach the same solution. But for me, I feel that it's better to model it as a binomial distribution, so the problem is easier for you to solve and understand. Then once we solve part A, then we just easily solve part B. We want to find out the minimal value of n, make that there at least one person have the same birthday as me. The probability is greater than equal to 0.5. Then we just need to solve this inequality. So let me clean the ink a little bit. So here, as what I mentioned, we can leverage on the complement rule to convert probability of greater or equal to 1 is 1 minus probability of x equal to 0. And then we just leverage on the solution we get for part A. We want to ensure this particular probability is greater or equal to 0.5. Basically, we just need to solve this inequality. So let's see how to solve this inequality. So this is the inequality we want to solve. Here, actually, we can just, if you forgot how to solve the inequality, it's quite simple. We just move this particular term to the right hand side and then move this particular term to the left hand side. Then it will become 1 minus 0.5 is greater or equal to 365 to the power of n. Basically, it's 0.95 greater or equal to 364 divided by 365 to the power of n. Basically, it's the same as this. So this is how to arrive this, in case you are not familiar with inequality. So actually, once you have this inequality, actually you can already using try and error method to find out what is the minimal value of n. So if you try in a calculator for a number of times, you will find out when n equals to 253, this particular number is equal to 0.49995. When n equals to 252, this particular number is equal to 0.5009. So in order for this number to be less than or equal to 0.5, the minimum number of n actually is 253. So this is one of the approach that you can solve for part B, but this try and error may need sometimes. If you are more familiar with some nature of functions, then if you recall, there's some function that can bring the power down, and then you can easily solve the inequality. That function is just about log. So if let's say you recall log a to the power of b, basically is equal to b log a. We can bring the power down. So this is the property of log. And the reason we can use this log transformation, by the way, this is called log transformation, is commonly used in computer science. The reason we can use this log transformation is quite simple. If you recall a little bit, the log function is look like this. So it's actually intersect with x-axis at y. And then you will see when x is increasing, y is also increasing. Hence, when we take the log to the both sides of inequality, for example, if let's say c is less than d, if we take the log at both sides, the inequality will hold. And the condition for we to apply the log transformation is that you can see the log transformation can only be done when this particular value is greater than 0, right? So before we apply the log transformation, then just let's quickly check whether it's greater than 0. So this number is just a 0 point something to the power of n, so it will between value between 0 and 1. So this is 0.5, hence we can safely apply the log transformation to this. So we can just take the natural log to the both sides of the equation, and then we apply to the formula just now we reviewed a to the power of b is equal to b log a. Then we can get n times log 364 divided by 365 is less equal to natural log of 0.5. Then you can just bring out your calculator to calculate the natural log of these two values. Then you can get the first one is negative 0.00274. The second is negative 0.69315. And then you can just calculate this, move this term here. Since this is a negative number, when we move from left hand side to right hand side, the inequality sign will be flipped. So we will eventually get n is greater or equal to 252.975. Since n is a number of person, it can only be integer. Hence, the minimum number that is required is 253. Hence that the final answer for part B is 253. So if you can properly model these particular problems in a binomial distribution, actually all the rest is just a trivial calculations. I think the only tricky part is that if you want to calculate this particular inequality, maybe let me clean the notes. If you want to calculate this particular inequality, the tricks that you will need to apply is the log transformation. So once you apply the log transformation, you will need to familiar with this particular probability B is equal to B